All right, welcome chemistry students. It is great to have you with me, and we are going to be diving into chapter 1 here. And as you can see from the title, we're going to be talking about matter and change. What I'd like you to do as you watch this video is you need to have out a notebook, piece of paper, and you need to be writing down what I ask you to write down. So these are your notes, and you'll be taking a picture of these notes and uploading them for me to see so that I can check to see that you watched the video. Okay? Now, as we go through this, there are some things that I will explain that you definitely need to know, and other things we're going to skip over just so that we can focus on and prioritize the things that are important for this chapter. Okay? All right, let's dive into this here. We're going to look briefly at section 1, and section 1 is just going to be talking a little bit about what is chemistry, and we'll focus on that. We're not going to spend too much time on the other two questions there in section 1, but we are going to spend a lot of time on matter, the properties of matter, and we're going to look at elements, and you should know that those are all located on the periodic table. Okay? All right, I'd like you to take a second and on your notebook, in your piece of paper, on your piece of paper that you're going to be submitting, I'd like you to answer these two questions right now. What is science, and what do scientists do? What does a scientist do? And these are kind of just opening questions just to get you to think right now. So go ahead and you can pause the video and answer those questions. That question, in addition to number 2, it says compare and contrast the properties of a metal spoon and a plastic spoon. You're just looking at the properties of it. What properties does it have? It could be physical properties or chemical properties if you're aware of those. Name at least 3 properties that are similar and 3 properties that are different. So again, pause, answer those 2 questions in your notebook or piece of paper, and then restart this video. Okay, you're back with me, and let's look at section 1.1. So I would encourage you in your notes to go ahead and write good notes here, like you could write chapter 1 at the beginning, and then section 1.1, and then make some bullet points or kind of have an outline of some form, and I'll tell you what to put in that. Okay? All right. It is known that chemistry is called a physical science, meaning it is it's a study of objects and materials, but specifically non-living objects and materials. Okay? So biology, you're studying life, but in chemistry, we're looking at non-living objects. Physics, astronomy, and geology are other physical science. Okay? So specifically, I want you to write this down in your notes. You would write down chemistry, and then write down this definition, and you can put it in your own words. Is the study of the structure and properties of matter. Matter is everything that we see around us. And it's also the processes that matter undergoes, and the energy changes that accompany these processes. So that's the entire unit, or the entire course, that we're going to be looking at. We're going to be looking at matter, all the stuff that is around us, and what is it made of, what is it, what are the properties, and then we're also going to look at the reactions that they undergo, or the processes, and we're going to look at energy. That's basically that's the entire course that we're going to be looking at. Matter, the reactions they go through, and the energy that is involved. Okay? You can write down this definition as well. Pause the video and write this down. A chemical, we're going to be looking at chemicals, is any substance with a definite composition. What that means is it has a definite arrangement of its atoms in order to have a certain way that it's made up. Okay, composition, the way that it's arranged. So for example, sucrose or sugar is made of carbon, oxygen, hydrogen, but they have to be in a particular ratio, a definite set composition in order to be sugar. Water, you're familiar with water, it has to be H2O. 2 parts hydrogen to 1 part oxygen in order to be water. Okay? So far you got chemistry and chemical. We're going to just skip over all of this here. We're not going to be responsible for that. But let's jump into 1.2 now. And let's focus on what is matter, since that's what we're going to be talking about. And let's look at what type of properties we're going to be examining. Okay. So section 1.2, you can put this in your notes, 1.2. One thing you need to know is you're going to write down this definition. Matter has two properties. It takes up space and it has mass. That's what matter is. Matter is anything that takes up space and has mass. And that's everything that we see in our world. Okay? So you can write the definition for matter. And then under that, you're going to want to write and explain these words that are in that definition. Mass. Mass basically is a measure of the amount of material, the amount of stuff that makes up that particular matter, that substance. Okay? And the second property is it takes up space, or we might say volume. It has volume. Okay? Make sure you know those two things. Now, if we dig down deep enough into any piece of matter, any substance, we are going to find atoms. Atoms are the building blocks of matter. You need to have this in your notes. I should see this when I look at your notes, when you turn them in. Okay? Now, an atom is a particular building block, and every element has a unique type of atom. So an element, you're going to want to write this down as well, an element is a pure substance that cannot be broken down into simpler or stable substances. So these are on the periodic table. You're going to have to write that down. These are all on the periodic table. And there's only about 100 of them, which is amazing to think that we only have about 100 elements in our world, but thousands, if not millions, of different types of substances. And we'll see why that is and how they combine in order to give us all these wonderful different materials. Okay? An atom, smallest unit of an element. So every element has a unique atom. Okay, you need to know that. Every element is kind of defined by its atom. It's kind of like its ID. And that atom right there, every atom of a particular element has the same chemical identity or properties. So every element is defined by its atom, and that atom, that element have certain chemical properties. Okay, make sure that is in your notes right there. Now, these elements can combine, as we'll look in a future chapter. We'll look at how these different elements and these atoms of these different elements combine to form compounds. So a compound basically is a combination of two or more elements. You're going to want to write that down. Compound. You basically have two or more elements that are bonded together. Yes, the compound can be broken into simpler, more stable substances. Okay, unlike an element, it could not be broken down. But a compound can be broken down, separated into the elements that make it up. Okay, so I already mentioned water, but H2O is a compound. It's made up of the element hydrogen and the element oxygen. Okay. Now, every substance has particular properties. It's really cool because you think about water. Water has certain properties. We need it for life, for one thing. But look what it's made up of. Hydrogen, which is a gas, and oxygen, which is a gas. So isn't it crazy, really neat, almost marvelous that hydrogen is a gas by itself, so is oxygen. By itself, actually, they travel in pairs. It's called diatomic. Hydrogen is a gas, oxygen is a gas, but if we get them to combine in the right ratio, 2 hydrogens to 1 oxygen, it forms water, which is a liquid at room temperature and has very different properties than the elements that compose it. Pretty cool. That's pretty remarkable. Okay? So let's look at some different properties here. Scientists love to categorize things, so one way we kind of look at properties is we define them either as extensive or intensive. You're going to want to write this down in your notes. Extensive means it does depend on the amount of matter. So if you've got a lot of something or just a little bit of something, this extensive property, whatever it is going to be different. Okay, so for example, volume. Volume is a property. Well, if you've got a lot of something, its volume is going to be much bigger than if you just have a little bit of it. It depends on how much you have. Okay? So volume, mass, if you got a lot of something, the mass is going to be bigger than if you have a little bit of it. Or the amount of energy. If you have a lot of something, you have a lot more particles moving around that carry a lot more energy collectively than a small amount of that same material. So extensive means it depends on how much you have. Intensive means it's kind of internal. It doesn't matter about the amount or the external aspect. Intensive means it does not depend on the amount. It doesn't matter if you have a large amount or a small amount. Let me give you some examples. Melting point. All right? If I heated this large amount up to a certain temperature of the same material as a small amount, they both will start to melt at the same temperature. It doesn't matter how much I have. Their melting points are the same. Their boiling points are the same. The density is the same. Density, by the way, is mass over volume. So this large mass has a large volume. This small mass has a small volume. But the ratio is going to be the same if they're the same substance. Density is intrinsic, or intensive, I guess we could say. Okay, so make sure you know these two definitions, and even the different types of properties would fall into those two categories. Okay? Okay, let's talk a little bit about two other ways that we look at properties. We look at what are called physical properties, and substances can undergo physical changes. Let me give you a couple examples. A physical property, this must be in your notes, can be observed or measured without keyword, without changing the identity of the substance. Here's a great example. If you boil water, here's liquid water in the beaker. If you boil it, it's going to turn into steam, which is just water in a vapor or gas form. It's still the same formula. This is H2O as a gas. This is still H2O as a liquid. You haven't changed the chemical composition. You've just changed its physical form or nature. Okay? So, when you boil something, or when you freeze something, or you melt something, those are just physical changes. If you take a piece of paper and you rip it up, it's still paper. Okay? So, a change in a substance that does not involve a change in the identity of the substance, or I might even add here, the chemical composition. It is still the same formula, H2O, even though it went through a change, a physical change. So make sure if you want to pause the video right here, and make sure you write down what you need in order to understand a physical property and a physical change. Okay? Anytime a substance goes through a state change, a change of state, that means it goes from a gas to a liquid, or a liquid to a solid, or a solid to a liquid. These are your three states of matter, right? Those are just physical changes. Okay? Those are just physical changes. Physical change, anytime it changes from a solid to a liquid to a gas, or in between any two of those, it's only a physical change. Okay? All right. I'm going to just skip down here. Well, we might as well talk about this right now. You should know this already. You should know what a solid is. A solid is, at room temperature, has a definite volume and definite shape. Okay, a block, for example, you can't change the shape of it necessarily. It's solid. The particles are packed closely together. A liquid, you know, it has a definite volume, but it can change its shape. It takes on the shape of the container that it's in. Okay. Its particles are pretty close together as well. But a gas has lots more energy, and those particles can move all over the place, and they don't have a definite volume. They'll fill up the container that they're in, and they will also take on the shape of the container that they're in. Okay? So here's a neat little illustration of the differences between, on the molecular level, of a gas, a solid, and a liquid. So you can see the gas particles are really far apart. Solid particles are packed even in a nice arrangement. Look how nice and neat they are. Okay? And liquid, they're packed close together, but really random. They're kind of vibrating, and rolling, and tossing, and turning and tumbling all over each other. Okay? So make sure you know and understand that. I would take a second and make sure you write these three things down in your notes. Okay? There is a fourth state of matter. It's not common, but basically plasma. It is it's at a high temperature, and its matter is made up of charged particles. So basically, It's when matter has some of its electrons stripped away. So the fourth state of matter, plasma, we see this in fluorescent bulbs and stars. So when you turn on a fluorescent light, there's gas particles in there, and they're charged up, and they're basically losing or getting their electrons excited and falling back down, up and down to different energy levels. We'll talk about that later on. The particles here in a plasma are influenced by electrical charges. Okay, so just think of it as a highly charged substance. All right. Now, the other type of property, we talked about physical properties. Now let's talk about chemical properties. As you can see, the word chemical there, chemical, we can think of maybe the chemical composition. The difference now is that this is a property, and it's describing how the substance is going to react. How does it react with other substances? Okay. So a chemical property relates to the substance's ability to undergo changes that transform it into something different. You started with water, but if you break it apart, you now have something different and two gases, hydrogen and oxygen. You started with a liquid water, and if you were to break that apart through a chemical process, you now have two gases. You're ending up with something very different than what you started with. This is a chemical change. Okay, chemical change, and that describes a chemical property of that particular substance. So a chemical change, the change in which one or more substances are converted into different substances. And that usually occurs when you have a chemical reaction. So take a second and make sure you write these definitions down, okay? I'll mention one other thing about this. The only guaranteed way to know that something went through a chemical change is that you have something different than what you started with. There are different observations that we make, like we may see bubbles produced, or we may see a color change, or we may see heat given off. But the only guaranteed way is to test the new substance, if we think there's a new substance, and see that it has new properties, see if we have something new. Okay? But we can make observations in the lab or during an experiment to see, oh, I think a chemical change is occurring because bubbles were produced, or because there's heat given off, or because I saw light, or something like that. Okay. So this is just showing you an example here of this illustration. It's showing you that you have an iron rod here and chlorine gas. You have iron rod inserted into this flask, and you have chlorine gas in here, and given time they're going to react and starts to form on this iron rod. There's something that is being deposited here because the iron and the chlorine are coming together to form iron chloride. Okay, so there's obviously a chemical change. You have iron and chlorine forming iron chloride. And we'll talk about the formulas for these later on, but this is an example of how we would show a chemical reaction. Okay, element of iron, element of chlorine. It's also diatomic, and they're coming together to form a new compound, something new, chemical change. Okay. When we write a chemical reaction, and this is an example of a chemical reaction or a chemical equation. Okay, we have things that are coming together, forming something new, or it could be the other way. You could have something that breaks apart into two things or three things. All right, but in our chemical reaction, we have what are called reactants and products. So the reactants are always on the left side, and the products are always on the right side. So I'd like you to write down this in words. I'd like you to write this chemical reaction down and make sure that you write above it or below it reactants and products. Anytime that we have a process, whether it's physical or chemical, there is the potential of energy being involved. Okay, so let's talk about energy and how that is a part of the process during these different changes, whether physical or or a chemical. Okay? Every physical change and chemical change requires energy. Remember, I told you at the beginning of this lecture that much of what we're going to study is about the energy involved in the processes that this matter goes through. Okay? Every physical and chemical change requires energy. You want to write that down right there. Okay? Now, this energy could be heat, it could be light, it could be even sound, it could be, we talk about potential energy, we talk about kinetic energy. Things that move have kinetic energy. Energy that is stored is potential energy. We'll talk about that later on. Okay? So for example, heat can cause the change of state in which water boils. In order for water to go from liquid to a vapor, you need to add heat. In order to do the reverse process, you need to take heat out of the material, out of the substance. Okay? You can use heat even to go further. So this is a physical change, water boiling, but you can also go further and add enough heat to have the water vapor break down into oxygen and hydrogen. This is a chemical change. Okay? But in both cases, energy is needed. That's the point here of this little section. So you need to wrap that up somehow in your own words and say exactly this. Every physical and chemical change requires energy. Very important. Now, one neat little law that we are going to carry with us throughout the entire course is this law of conservation of energy. Okay? Energy is not going to be created or destroyed. It may change form, but it'll always be conserved. So you need to write down the law of conservation of energy and probably figure out how to say this in your own words. The idea here is that before reaction and after reaction, in every case, the total amount of energy present before the change is also present after the change. It may be in a different form, but the amount of energy before has to equal the amount of energy after. Okay? Energy can be absorbed into the substance or it can be taken out of the substance. But in every case, that energy, if it's being taken out of the substance, is going somewhere else and it's conserved. Or if you put energy into a substance, it's coming from somewhere else and it's still conserved. Energy before equals energy after during any physical or chemical process or change. Okay? Very, very important. Okay. We already talked about elements and compounds. Let's break down matter just a little bit more. So you might want to have a little heading here about matter. And let's talk a little bit about matter and how we kind of categorize matter in different ways. Any sample of matter can be classified as either pure or a mixture. So matter can be either pure or a mixture. And hopefully this is pretty elementary. A pure substance can be either an element or a compound. See how I'm making kind of like a little chart here. Element or a compound. So water is a compound, but it's pure. If it's pure water, it's H2O, and nothing else is in that H2O. It's only H2O. Or an element, hydrogen, or anything else on the periodic table, those are all pure. But a mixture then would be anything that is composed of different compounds or a combination of different things, different substances. Okay? Mixtures contain more than one substance, and the properties within a mixture can vary from sample to sample. So for example, in a pure substance, over here, hydrogen is pure. If you have pure hydrogen, its properties are set. You will know that it always is going to behave as hydrogen. Water, if you have pure water, it's always going to behave as water. But if you had a mix of gases over here, like if you had hydrogen and oxygen, and you had some helium, and you had other gases, okay, depending on how much you have of each of these, that mixture of gases might behave a little bit differently. If you had a lot of oxygen or a lot of hydrogen, it might be very flammable, it might combust. But if you had mostly helium, Helium is pretty inert. It's not going to combust. So it depends on the mixture and the ratio and how much you have of each, or you know, the degree to which you have these three or more gases. So it varies. These are all set, okay? Pure substances are pretty set. Mixtures, as it says here, the properties can vary from sample to sample, okay? So, for example, samples from different places on a block of gold will have the same composition. That's pure, 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 pure gold. Every sample, every little portion that you take of the gold, it's going to behave and react the same way. Okay? But samples from different places in a large rock. A rock is just composed of different types of minerals and different ores and whatever. That rock, depending on where you take a sample from that rock, you might be getting a lot of one type of mineral or one type of material from a different spot, and therefore it's going to behave differently. Okay? So you might want to pause and summarize that idea. Now, mixtures, if I was going to continue my chart here, mixtures can be either homogeneous or heterogeneous. So you might want to draw your chart here. Mixtures are broken into homogeneous and heterogeneous. And all that means is any mixture, we already know that it's a blend of two or more kinds of matter, okay? But homogeneous means it's pretty uniform throughout. Even though it's a mixture, it's spread out evenly throughout the mixture, okay? So for example, if you had salt water, the salt is going to dissolve and pretty much distribute itself evenly throughout the water, so that if you were to take a sample from here, it's still going to be salt water, probably with the same type of composition. Salt from here, if it doesn't matter where you take your sample, you're going to have the same consistency of salt water. Okay? So homogeneous means it is uniform throughout the mixture. Heterogeneous means it's not uniform. You might have a clump of something here and a clump of something different over here. It's a mixture. It's just somebody didn't do a very good job of mixing it up evenly. Okay, you just got different clumps of stuff. And if you were to take a sample from your mixture here, it might be very different from your sample over here. Okay, if you look on a milk carton, often it will say homogenized. What does that mean? Homogenized just means that they took the milk through a certain process so that the fat and the water and the milk and everything that is in that particular container is more or less evenly distributed. Not perfectly, but they don't want all the fat of the milk floating on top. So they go through a process of homogenizing it, spreading it out evenly throughout the container, throughout the gallon milk jug. Okay? Heterogeneous, again, it's not uniform. That would be, for example, clay and water. So maybe you've got a container where a lot of the heavier stuff is on the bottom and a lot of the lighter stuff is on top. Okay? It's kind of separated. Maybe the heavier stuff goes to the bottom. It's maybe silty or dirty or whatever, but still you kind of see maybe different layers as a result of it not being particularly and perfectly uniform. Okay? So here is the diagram that I was telling you about. You can continue to write this in your notes. Matter, can it be separated? No, it cannot. If it cannot, then they're pure substances. And what pure substances do we have? Elements and compounds. Basically, compounds can be broken down into elements. Elements cannot. And mixtures, over on this side, is it uniform throughout? Is it evenly spread? If it is, we call it homogeneous. If it's not, it's called heterogeneous. That's a great chart for you to put in your notes. Okay? Super, super study tool. Now, one neat thing that we can do is we can use these properties to separate stuff. So we can use different properties to separate stuff. So for example, in this picture right here, this person is pouring a mixture through filter paper. Well, the substance that is larger in size is going to stay inside the filter paper, and the stuff that's smaller in size is going to pour through. So this is going to separate substances based on what property? Size. This is a great thing to write down. So separating mixtures, we use properties. Using different properties allows us to separate items that are in a mixture. Okay, it allows separation. So if you pass something through filter paper, you'll separate the components, and that is because of the size of the particles. There are other ways that we separate things. Chromatography, centrifuges. We also use distillation. That's separating it based on its boiling point. Okay. Hopefully you'll be able to do maybe a little experiment that demonstrates that. Pure substances are not separated. Okay. It has a fixed composition and differs from the mixture in the following ways. Every sample of pure substance has the same physical and chemical properties. Okay? And every sample of a pure substance has exactly the same composition. H2O is always H2O. Always. It's always in that ratio, in that combination. Okay? All right, we're going to skip ahead here. And we're going to jump into our last section. And our last section is looking at elements. Feel free to pause this video, of course, during any time if you need to take a break and come back to it. Right? Break it up a little bit. I know it's hard to sit and just go through a video in one sitting, but pause it, take a little break, come back, finish it up. Okay, elements. Now this is section 1.3. So in your notes you could write section 1.3, elements. Okay? Elements are pure substances. They cannot be broken down anymore. An atom is the smallest building block of that element that keeps its properties, that keeps the properties. All of the elements are located on the periodic table. Okay, they're organized in a particular way on the periodic table. Very, very powerful tool that we're going to be using a lot in this course. Now, the complete periodic table has all the names of the elements, and they follow what is called the periodic law, which we'll look at in an upcoming chapter. And they're organized in a particular way. It's not random. It's really, really cool table because those elements are arranged in a particular way because of the properties. We're going to talk about this later on, but all you need to know right now, if you write this down, the periodic table organizes elements by their chemical properties. We're talking about properties here. So this is key. You need to know this right here. Okay? On the periodic table, you need to know this, the vertical column. So on a periodic table, you've got columns, and each box is representing a different element. The vertical columns are called groups. So this is a group. Okay? Or it might be called a family. So this is a group or a family. And that's because they have similar properties. I told you they're organized by properties, right? Similar properties. And then going across, you have rows. And those rows are called periods. And we'll look at why we have different periods. Why not just keep going or going down one row? Why do we have different, or one column? Why do we have different rows? We're going to look at why that is. Okay? Really cool stuff. So, groups or families are columns. So this is a particular group or family. This is a particular group or family. Over here, you'll notice group 13, group 14, etc. Okay? Now this portion down here, the periodic table, it sometimes is pulled out and put below, but it actually fits in right here, and the whole thing is elongated. It's actually wider than it appears, but sometimes it's pulled out in order to make it easier to put on a piece of paper. Okay? As mentioned, the horizontal rows are called periods. So this is period 1, period 2, period 3, period 4, and so on. 5, 6, 7. All right? Okay. On the periodic table, because these are grouped by their period or by their properties, you'll notice that if everything in a column has similar properties, then those that are pretty close to each other probably behave in a similar manner. And it ends up that everything over here on the left side, these are all metals. These are all metals. Over here on the right side, these are all nonmetals. Okay? These are all nonmetals. And then in between, you have some that kind of behave a little bit like both, depending on what temperature they're at or what they're bonded with. Those are called metalloids. But you can see that predominantly on the left are metals, predominantly on the right are nonmetals, and the stair-step border in between, those are your metalloids. Okay? And that's what it says here. Metal. And you see the properties here? Good electrical conductor, good heat conductor. So all the metals have similar properties over on the left side. Nonmetals, they don't conduct electricity, they don't conduct heat very well. So you can see the properties are similar. All right, we're going to just roll past these a little bit here and wrap this up. Nonmetal, poor conductor of heat and electricity. You want to write down metal and nonmetal to make sure you know the difference between those. Okay, there's some examples here. Okay, nitrogen, oxygen, fluorine, chlorine, etc. are all nonmetals. One last thing here. Sometimes the different, I mentioned metalloids, right? Metalloids are the stair-step border in between the metals and nonmetals, and those have characteristics of both, depending on what temperature or how they are treated. These different families or groups sometimes are broken into these different columns, I should say, and they're given different names. So I'm just going to give you really quickly here some names, and I want you to write these down. Okay? So group 1, right here, these are called the alkaline metals. Group 2, these are the alkaline earth metals. So group 1 and 2, you should know the names of those. Over here, we have group 17. Those are the halogens. Make sure this is in your notes. And group 18 are the noble gases or inert gases. Okay? Those are a few groups that are very common, and so I might refer to those instead of just saying the group name. Okay? So that pretty much wraps up this chapter, chapter 1. If you have any questions, please don't hesitate to contact me, email me, or talk to me live when that is available. If you also probably what you want to do is take a moment and see if you can answer these review questions that are at the end of each section. Okay, that's on your own. You don't have to do that, but it's a good test for you to see if you can answer those, because those could be great test or quiz questions that I might ask you. I might pull them straight from this note sheet. Okay, so just keep that in mind. All right, you have this available to you, this particular document, in your Google Classroom, and you can refer to it at any time. Okay, all right, that wraps this video up. Make sure that you take a picture of your notes, upload it into this assignment so that I can give you credit for this, and we'll see you at the next video. Great, thanks, good job.